It's happened. For the first time in more than half a century, we've sent humans around the moon and brought them back home. The Artemis 2 crew, they're back, safe and sound. Their splashdown wasn't just a landing, it's really the start of a whole new chapter for us in deep space. So let's get into it, the story of this absolutely historic flight.
And you know, that's not just hype. This quote from NASA, it really nails the feeling here. This wasn't just one mission. Think of it as the crucial first step, right? The test run for this incredibly ambitious plan to get us living and working on the moon, and from there to look towards Mars. So here's the bottom line. After 10 days out there, a journey that took them to the far side of the moon and back, 4 astronauts are home. And they're safe. Their mission was, by all accounts, a huge success. They pushed the technology, they tested the procedures. Basically, they did everything needed to pave the way for what's coming next.
Okay, so let's dive into what this mission actually pulled off. Because when you look at the numbers, they're pretty mind-blowing.
Yeah, look at that number, 406,771 kilometers. That's a new human frontier right there. We're talking over 250,000 miles from home. Back on April 6th, the Artemis 2 crew just flew past the old record set by Apollo 13. They are now, officially, the people who have traveled the farthest from Earth, ever.
And this really just sums up how well everything went. I mean, it was a perfect 10-day flyby of the moon. The crew came back happy and healthy, which is exactly what you want to hear. The landing itself, they're calling it a textbook touchdown, hitting its target in the Pacific with just incredible accuracy. And maybe most importantly, all along the way, they were gathering tons of data that's going to make all the future moon missions that much safer and more effective.
All right, now let's get to the most intense part of the whole thing, the return. You know, those final moments of any mission, coming back to Earth, are always the most dangerous. And for Artemis 2, the descent was a literal trial by fire.
Okay, try to wrap your head around this speed. The Orion capsule slammed into our atmosphere at over 24,600 miles per hour. That is insane. It's 35 times the speed of sound. To put it another way, you could cross the entire United States in about 6 minutes at that speed. The heat shield had to take on temperatures hotter than the surface of the sun just to keep the crew inside safe. Just incredible.
And during that insane re-entry, all that friction creates this bubble of superheated gas, plasma, that just wraps itself around the capsule. And what does that do? It cuts off all communication. For 6 long, agonizing minutes, there was total radio silence between the crew and mission control. Imagine being on the ground, just complete silence, waiting, and trusting that all the engineering, all the math, was holding up on the other side of that wall of fire.
So this is how it all went down, the final countdown to splashdown. At 23:33 GMT, Orion separates from its service module. That's the part with the engine and life support. Now it's on its own. 20 minutes later, bam, it hits the atmosphere at 35 times the speed of sound. Then, things start to slow down. At 3 minutes past midnight, the first parachutes pop out to stop it from tumbling. A minute later, the 3 huge main chutes unfurl for that final, gentle drop. And then, at 7 minutes past midnight, splashdown. A perfect landing, right in the Pacific, right on time.
But you know, a mission like this, it's not just about the numbers and the engineering. It's a really human story. It was felt deeply by the families, the educators, and the team that made it all happen. So let's hear from some of them. This one gets you right here. This is from Ashley Hansen, the daughter of Canadian astronaut Jeremy Hansen. She was just waiting for her dad to get home so she could hear his story. It's just such a powerful reminder that inside those super advanced spacesuits are, well, they're parents, they're people on the adventure of a lifetime.
And this quote, this really puts it all in perspective, doesn't it? Pam Leesma, a space educator, remembers watching Neil Armstrong walk on the moon when she was in 10th grade. For her, and for so many people, this feels like passing the torch. This is it. The next generation, the Artemis generation, is taking that next giant leap for all of us.
You gotta love this one. This is from Howard Hu, the Orion program manager. He's talking about how he felt, and he compared it to seeing Star Wars for the first time as a kid. But then he said this was thousands of times better. I mean, that just tells you everything, right? It's about that pure joy, that inspiration you get when you see science fiction become science fact. So all these amazing human moments really highlight how important this was. But let's zoom out. Beyond the inspiration, there's a really big question here. Why does this mission matter on a global scale?
And to answer that, we've got to talk about the cost, the potential payoff, and the really high stakes of this new space race. Yeah, let's just get right to it. Going back to the moon is not cheap. By 2025, the Artemis program is expected to cost over $93 billion, and honestly, that number is probably going to go up. So it makes you ask a fair question. How do you justify spending that kind of money?
Well, NASA makes a pretty strong case for the return on that investment. For one thing, the program supports almost 20,000 jobs and pumps billions into the economy through new tech and industries. But looking bigger picture, this is all about laying the groundwork for a future lunar economy. We're talking about developing the ability to maybe one day harvest things like water ice from the moon's poles, which could be turned into rocket fuel or used for life support. But there's another reason, and it's a big one.
And this right here is a really critical point from Congressman Frank Lucas. The US isn't the only one with its eyes on the moon. China, for example, has been very clear about its goal to land its own astronauts there by 2030. So this isn't just about science anymore, it's also about geopolitics. The country that gets there and establishes a presence first will get to set the precedents, to help write the rules for how we all operate on this new frontier. And that brings us right here. The success of Artemis 2 leaves us with this huge question. We've just proved we have the tech, that we can do this again. But now, as we're standing right at the dawn of this new Artemis generation, the challenge isn't just about getting there anymore. It's about deciding what kind of future we're going to build once we arrive. Who's going to write the rules for space? It's